And it is Ellis Yoakum,
Yuki Seichern.
and we are going over the design process today. And this is us.
For the problem that plagues most students in college, and it's the fact that college is not, in fact, cheap.
So when we were coming across this problem, we were sitting in the library and we were wondering, what is a big problem right now? And a problem that impacted both of us really bad was the cost of tuition. We're both starting college and we were just now understanding that college is not cheap. So we decided that that is a good basis. We have a bunch of places that we can go with that problem, and it'd probably be a good place for what we want to use to have a problem for this semester. So coming to our problem statement, we started off with a really different problem statement at the beginning. It was one that we probably couldn't really build off of. It was kind of contained, I'd say. There's really nothing we could do with it. So we ended up switching it a couple times, and we came to the conclusion of this as our problem statement.
So as you can read on screen, it is what can be implemented to help reduce costs of attending GBSU as an undergraduate student. So for our top three, our first solution was motion detection lights. Walking around campus, you'll see that most buildings have their lights on during the night, which exponentially increases the electricity costs for the school. So if we can reduce it, hopefully tuition should be lowered as well. So the plan was to use motion detection lights to minimize the usage of unnecessary lights.
The next solution that we had not decided on was in-house food production. The university consumes a lot of food, and that gets expensive over time, and especially with the rising inflation. So it was just a new idea. It could also help with other programs in the school, like if there's an agriculture program, they can be out there and they can be helping, make this stuff. It can help the engineering program for something to build, and it's just an all around cool idea. There's a lot of ways we can improvise it and also make it better. We can make it just more cost reductive for food, or we can also help educate others while we're going through the problem.
The third solution was competency-based learning. The background of this comes from the fact that the majority of the cost comes from the credits needed from classes. The plan for this was to implement a test for students to test out a class. If they proved proficient, they would gain the necessary credits for that class, therefore reducing the cost.
The one that we ended up choosing was in-house food production. We chose this because there's a lot of different ways we can go with this. We can branch off into different cool areas that have not really been explored with it. I have seen a couple of in-house or food productions going vertically, but not many where they reuse the water using gravity. So that was one of the main reasons that I really want to do this. It's just the new ways we can implement it, and also just the cool design it would be when we are building it. Prototyping phase. Most of the ways that they were trying to do it, I kind of already had an idea of how we were going to do it. So we were thinking of the best ways we can save money and how we can get the most out of it while we are saving money. So how we did this is we kind of just spit out ideas of how we can make this the best we can, and then we drew a couple of sketches based off of them ideas, and then after that we picked the ones that would seem the most resourceful while also being materially efficient. And then after that, we just improved on the ideas until we came up with kind of a prototype or a concept. So as you can see, here is our prototype. We have a two modular system, one with the actual piece and another with stilts. The piece is kind of a triangle. It's kind of a strong structure. It's held together by cables holding the tubes that are cut in 2/3. So basically the water can come in, and then it uses a French drain to take water out of the soil and drip it down to the next layer to help not waste water. And yeah, it's kind of the whole idea around it is to lessen the amount of area that we have to use for planting while also maximizing the resources used and getting the most out of what we